Let's do x plus 3 quantity squared is equal to 16. Now, there's a little bit of a problem. I told regular class last week, this is a case where you can't get your x squared by itself because of the way it's set up. Have you ever gotten a Christmas present or anything where it was like a package and a package and a package like that? I saw one on YouTube. I saw one on Facebook this morning that was a boy's birthday yesterday, and his mom, man, she had done some major wrapping. And he had, I thought, is he ever going to get to that package? Because and I don't even know what the final result was, because I was looking at him opening his gifts. Started out this big, another one, another one, another one. I didn't know how they got that many boxes inside of all those boxes. But what happens here, x plus 3 squared. Now remember, please remember this, because the ACT loves to give you a problem like, you know, and I can even do that one. X plus 3 quantity squared, I'm thinking we might have done this the other day, maybe not, is never and will never be x squared plus 9. And the ACT knows that you think that sometimes, even though you know better, because, and they will put that as an answer, and good students mark it, because it's just, they look at it that way. But you have to remember what this means. It means this, which gives you x squared plus 3x, which is 6x plus 9. And so it's actually a trinomial. And so when you do this, you've done the L, you've done the L, but you forgot to do the O and the I. So you have to think about what that means. Because of that, you can't get that x squared by itself, the way it's set up in that package. So to do this, you're going to have to get rid of the squared first. Let's do this. Now, before I do that, I need to go over to the side. Let's go, we can do it actually up here at the top. Do you agree, we kind of have to review something. Do you agree that the square root of 8 squared is 8? Is that true? Okay. So what's the square root of x squared? We just did that. X. What's the square root of m squared? M. So what would be the square root of x plus 3 in parentheses squared? X plus 3. So in this case, because this outer gift wrapping is a squared, we're going to have to get rid of it like that. You can't get rid of the 3. You won't have an x squared because you don't have just an x squared in there. You have an x squared plus 6. You have an x squared and a 6x. And you can't get x by itself. So your only choice is to do that. Now here's the kicker. X plus 3 we agree with. Now the square root of 16 is 4. And a lot of people do that. And then they go, well, now how am I going to get 2 answers? Because it's got a quadratic. It's squared. It's x squared plus 6x plus 9. It's got to have 2 answers. But remember, in a quadratic equation, the square root of 16 can be positive 4 or negative 4. And I need to put that and put a star there because that's where a lot of people miss it. Now, they do want to go. I'll show you what they want to do. And I'll show you why that doesn't work in just a second. So if I have x plus 3, now look what that means. That means x plus 3 equals 4, or, and put the positive there if you want to, x plus 3 equals negative 4. Now look what's going to happen. You're not going to get opposite answers on this one. Because this one will give you 1, and this one will give you negative 7. And there's your 2 answers. It's more like lesson 27. Because you're going to get 2 rational. I only gave you rational on these. So this one would have factored if you'd have done a whole lot of algebra. You'd have done a whole lot of algebra to get there. Now, let me show you, and I'm not going to work it wrong on here. But here's what a lot of people want to do. They want to do, because if you go back excuse me, if you go back to the original, 1 plus 3 is 4. 4 squared is 16. If you put -7, you get -7 plus 3 is -4 squared. -4 times -4 is positive 16. Because a lot of people want to do this, subtract the 3, and they want to say, minus 3. What am I doing? I don't know. And I get x equals 1, and they want to put plus or minus there. Well, when you put 1 in, it does work, but when you put -1 plus 3 is 2, and 2 squared is not 16. So it's not opposite solutions on that one like it was on this page. So that's why I separated those. Now, to me, they stand out because it's an x in a package. It's x plus 3 squared. So you got to get rid of the squared first, then you got to get rid of the 3 in 2 different ways. Let's do one more, and then I'll let you work. Let's do 2x minus 5 in parentheses equals squared equals 36. Now, I only gave you perfect squares here. I'm going to save the ones that are irrational, complex, till we get into the quadratic formula. You just got to learn how to write them, and the quadratic formula will help you on that. So this one's in a big package. It's got a squared we got to get rid of. It's got a 5 you're going to have to get rid of, and a 2. So you've got the x with a lot of stuff around it. So we're going to square root both sides, and we get 2x minus 5 is equal to positive or -6. And again, put a star by that because that's where you'll have to watch it in your notes. I think it's the last 4 in your classwork. So now 2x minus 5 equals 6, or 2x minus 5. And the biggie there is, don't forget it has 2 answers. And in this case, because you're getting rid of a 5 and a 2 with a positive or negative, they're not going to be the same because this one's going to give you 2x equals 11. And, Caroline, we're going to leave it 11 over 2. Is 5.5 fine? Yes. But if it had been 11 over 3, I don't want decimals. If it's 11 over 7, it repeats 6 decimal places. You just don't see bar notation that much anymore. So we tend to just do that math frac key and change it back to a fraction. And then plus 5. It just works consistently across the board. Now, we've got some stuff coming up that we're actually going to have to round. Because when you do some irrational stuff and it gets really crazy, I'm talking and not adding right, -1 divided by 2, and the other answer is -1/2. So you've got two, or -0.5. You've got 2 solutions that work, quadratic. So you've got 2 sets. I did not mix them together. And I told regular, these probably you use more. Well, I don't know. It's just, you'll see these, the simple ones. I call these the simple ones on this page, and these are a little more complicated, but they're not that difficult.